here, according to my clock. Is that good? Um, so all the audience out there, I'd like to welcome you. I'd like to welcome our panel of space agency leaders and our audience, COSPAR associates, to this roundtable discussion. Um, the Roundtable of Space Agency Leaders is actually a tradition in the COSPAR Assembly. It's our opportunity to listen to and to engage with the leaders of space agencies from around the world. There are, of course, as you might imagine, there are many space agencies. So the question you might ask is, how do we choose the leaders of these space agencies for this roundtable? Which, although is all in virtual space, is nominally in Sydney, Australia. First, we asked the leaders of regional space agencies to find in a very broad geographical region, essentially Asia and related places. This includes, of course, Carl Rodriguez of the Australian Space Agency, Andrew Johnson representing the New Zealand Space Agency, Wang Qi of the National Space Science Center of China, Hitoshi Kumanaka of the Institute of Space and Aeronautical Science of Japan, and S. Somanath of the Indian Space Agency Research Organization of India. But then, of course, since COSPAR promotes international cooperation, we included the major space agencies from elsewhere in the world that the regional space agencies in this broad region are most likely to cooperate with. And this is Gunther Hasinger of ESA, Walter Peltzer of DLR of Germany, Jean-Yves Le Gall of CNES of France, Anatoly Petrokovich of IKI in Russia, and Thomas Zurbuchen of NASA of the United States. And then we added, as a prelude of things to come, the space agency of the location of the next COSPAR assembly, which is in Athens, Greece, in July of 2022, Ioannis Douglas of the Hellenic Space Center of Greece. Now, it is obvious that our panelists come from all over the world and are currently in the full span of time zones. And thus, we chose a time for this virtual roundtable that is inconvenient for the least number of panelists. And I want to thank in particular Carl Rodriguez of Australia and Andrew Johnson of New Zealand for sacrificing their night's sleep so the rest of us can be awake for the roundtable. So let's begin. We're going to show now a 44-minute video of pre-recorded remarks from each space agency leader. In some cases, the leaders on the video are slightly different from the ones on the panel, but they're all part of the same organization. We have asked that they consider focusing their remarks on the interest of the agencies on several possible topics, things like climate change and space weather and astrophysics and small satellites, and of course, with a particular emphasis on international cooperations. Now, while these remarks are playing, I ask you to submit questions. Please use only the Q&A box so as not to get this thing too confusing, not the chat box for asking your questions. Jean-Claude Varms will then gather together questions with a common theme. He will pass them to me, actually using the chat box, when the video ends, and then we will return to the panel, and I will coordinate a discussion with the panel to answer the questions. And if you don't have any good questions, I got some good questions. So we expect to have a lively discussion after the video has played. So Jean-Claude.
Can you see the screen now?
Yes, we can.
Okay, I'm launching the video.
Hello, I'm Carl Rodriguez, Acting Deputy Head for the Australian Space Agency. Ahead of the roundtable discussion, I wanted to focus on the topic opportunities and projects for the sustainable use of small satellites for space research. I will do this by highlighting some projects that the agency is funding, as well as other industry examples that are helping transform our space sector. Our International Space Investment Initiative is an investment of $15 million over 3 years to support Australian participation in space activities internationally. It supports strategic space projects that build relationships with international space agencies and companies with its purpose to grow Australia's space sector capability. The initiative is currently being rolled out, and it includes 10 projects to support industry growth from CubeSats, artificial intelligence and automation to the next generation of spacesuits. 4 projects as part of this investment have a small satellite focus. The first is a microsatellite constellation launch system by Skycraft. This includes the design and qualification of a satellite system for the deployment of Australian-designed microsatellites into low Earth orbit. The second is a decision support system for collision avoidance of space objects from the Industrial Science Group. This software will help satellite operators assess risks to satellites from collisions with other satellites and space debris. The third is an advanced GNSS receiver for CubeSats, rockets and remote sensing from the University of New South Wales. This project will modernise and extend the only Australian and New Zealand single frequency GPS receiver. This project will make the receiver fully capable of being used with multiple frequencies, antennas and systems. The fourth, the Spirit CubeSat mission in particular, is a project being led by the University of Melbourne. This mission will break new ground in high-performance autonomous operations, communications, propulsion and thermal management. One main payload for advanced X-ray remote sensing will be on board, known as the Hermes constellation. This has been developed for this project with funding from the Italian Space Agency and the European Commission. This will be able to quickly spot gravitational wave events by detecting the X-rays they emit and use triangulation to help determine the direction of the source. This project will also demonstrate the viability of Australian products in the global supply chain of satellite components. CSIRO is also collaborating with Innovore Technologies, a South Australian-based satellite company, to design and build a CubeSat with a suite of infrared sensors. The satellite is called CyroSat-1. The satellite is being supported by a collaboration with various research organisations, including the University of New South Wales, Canberra, the Australian National University Advanced Instrumentation and Technology Centre, and the Defence Science and Technology Group, who are supporting the mission design, testing and commissioning. It is a research and development platform that will inform our ability to design, build and operate future satellites that could track fires and study the formation of clouds and tropical cyclones. Linking back to the topic of focus, the highlighted projects can help support the sustainable use of small sats in a variety of ways. By ensuring the safety and positioning of satellites in orbit to avoid collision risks, by providing performance and accuracy improvements both in timing, position and or velocity estimation due to improved GNSS receivers, and by demonstrating the viability of Australian products and materials in the global supply chain of satellite components. Overall, these projects can help support and inform future small satellite missions going forward from both technology and research perspectives. Thank you.
Good day, ladies and gentlemen. My name is Wang Ce from the National Space Science Center, Chinese Academy of Sciences. I would like to discuss 2 topics. One is about the space weather mission and the ground-based monitoring network in China, and the other is about the international cooperation in the lunar and planetary exploration. Solar activity is the main driving source of space weather. ASOS is the first Chinese solar mission to study 2 types of solar storms, solar flare and coronal mass ejections, and their relationship with the solar magnetic field. It will be launched in early 2022. As the solar storms hit Earth, we need to understand the response of the geospace. The SMILE mission is a joint mission between the European Space Agency and China to investigate the solar wind magnetosphere interaction in a global manner. It will be launched by the end of 2024. China has also developed a ground-based program to monitor the key space environment parameters. The Meridian project will consist of more than 300 ground-based instruments in 36 observing stations across China. As the international extension of the Meridian project, the International Meridian Cycle Program (IMCP) is proposed to collect the 120-degree east longitude and the 60-degree west longitude chains of ground-based monitors to obtain the full coverage of the geospace process worldwide. As for the lunar and planetary exploration, China plans to go to the Moon, Mars, asteroid, and the Jupiter system by 2030. In January 2019, the Chang'e 4 probe landed on the far side of the Moon for the first time. Chang'e 4 carried 4 international payloads developed by the Netherlands, Sweden, and Germany. With the asteroid sample return mission planned in 2025, China has called for proposals on 8 types of scientific instruments on board this mission among universities and research organizations, both at home and abroad. In the future, China has initiated the International Lunar Research Station, which is to be located in the lunar South Pole region. It will be developed through a number of upcoming robotic Chang'e missions across the 2020s and expanded through the 2030s. Both Roscosmos and the European Space Agency had discussions with China with regard to contributing to this project. I think I will stop here. Thank you very much for your attention.
Ladies and gentlemen, dear colleagues, every other year, the COSPAR Assembly is a highlight event that brings together the global space research community. And let me first express my gratitude to Australia for organizing this 43rd Assembly in such difficult times. CNES was the first international partner to sign a Memorandum of Understanding with the Australian Space Agency as early as 2018. One of the first concrete steps of this cooperation was a partnership with UNSW Canberra to develop the Australian National Concurrent Design Facility. It is my honor here to say a few words about CNES actions in space research, which is built on international cooperation serving the global community. The past and coming 2 years are packed with exciting science in all domains. Nicolas Copernic will certainly forgive me for saying that today the center of the solar system is Mars, with 3 missions currently approaching the red planet. We will particularly be following the landing of the Perseverance rover with the French SuperCam instrument on board. In the solar system exploration category, let me mention also ESA Solar Orbiter mission, to which CNES is contributing, which is now beginning to acquire science data as it approaches to within 40 million kilometers of the Sun, becoming the first space probe to observe its poles directly, and the return of tiny particles collected from asteroid Ryugu by Japan's Hayabusa 2 mission that will be the subject of extensive scientific investigation this year. Soon to be sent to the L2 second Lagrange point, 1.5 million kilometers from Earth, ESA Euclid mission will seek to unlock the secrets of dark matter and dark energy. Back in the vicinity of Earth, but still in the field of exploration, ESA astronaut Thomas Pesquet from France will be flying again to the International Space Station this spring. There will be 14 French scientific experiments on board. Last but not least, CNES has been committed to studying our planet and its changing climate ever change since its inception, and this is continuing. We are working to support concrete actions like the Space Climate Observatory, to which 27 space agencies and governmental organizations have already signed up. The US-French SWOT mission is in final development stage, progressing well in spite of the logistic challenges posed by the pandemic. This year, the EMERA-3 and Strateol-2 scientific balloon flight campaigns will enable research into Earth's upper atmosphere, while Sentinel-6A will take over the operational responsibility of extending the landmark sea level climate data record initiated by Topex Poseidon. 2021 also marks the 60th anniversary of CNES inception. I'm very proud to report on our activities, which owes so much to our agency's engineers and to our national space sector, research institutions, space manufacturers and downstream sectors, startups, administrations, and of course, our international partners. Our conviction is that they are all part of the same space environment and that investing in science, research and development is a way to keep innovation going and to push the boundaries of progress. Science is our cultural heritage and our future. Let us preserve it.
Dear colleagues, the modern scientific community faces global challenges. Our changing climate is just one example why space research and the cooperation promoted by the COSPAR Scientific Assembly are more important today than ever before. At the German Aerospace Center, our 10,000 employees share our common drive to explore Earth and space and to develop technologies that will enable a sustainable future and growing economies. Remote sensing data produced at DLR, for example, is used to document the effects of climate change and to detect and analyze crop failures. DLR also works closely with humanitarian aid organizations. We offer them precise and timely geographic information available to aid workers on the ground. The satellite information allows them to quickly gain an overview of situations that require a rapid response. Meanwhile, our mobile greenhouses demonstrate how technology developed for space research can be applied on Earth. In addition to supplying astronauts with tomatoes and lettuce, these greenhouses could be used to provide fresh food for people in crisis areas who have lost their primary sources of nutrition. Space debris is another growing concern that many of us here are actively engaged in. The scientific and commercial use of space depend on the avoidance and removal of this debris. Researchers at the DLR Institute of Technical Physics are working on a laser-based observation method to precisely determine the positions of objects in Earth's orbit. We combine time-of-flight measurements made using a laser with its position in the sky. By doing so, we can determine objects orbiting at an altitude of 1,000 kilometers to within just a few meters. These precise measurements will enable satellite operators to conduct more efficient collision avoidance maneuvers. Such research requires investment. Ideally, this can take the form of new institutes, such as the Institute for Solar Terrestrial Physics. Here, we study the effects of space weather on the crucial power grids and satellite navigation and communication infrastructures. Regarding the space economy, it is clear that new space practices are driving and shaping the current growth. DLR places great importance on the support and promotion of startups in the space industry and the application of space technologies on Earth. Caring for the elderly and infirm using robotics technologies originally developed for use in space is just one example of this. As researchers and engineers, we are convinced that our joint research is capable of crossing borders, connecting nations, and bringing together people from different cultures. I wish you all many interesting discussions, new insights, and success at COSPAR 2021.
The Hellenic Space Center is one of the youngest, if not the youngest, space agencies worldwide. It was established 1 year ago and still struggles to overcome the bureaucratic hurdles associated with every single step towards full functionality. Being part of the wider public sector, we have to observe very strict rules regarding procedures and in particular regarding employment. Therefore, staffing has been extremely slow-paced. Nevertheless, we have already launched activities that do not require staff besides our governing board, which is composed by leading scientists and engineers of our country. Our activities so far include, first, advice to the Minister of Digital Governance on space-related issues and activities. Second, consultation with academia and industry. And third, contact with non-governmental initiatives of young space enthusiasts. Our advice to the minister has focused on Greek participation to programs of the European Space Agency and of the European Union, and on the representation of Greece on program boards of these two organizations, and also on the development and implementation of a small satellites national program. The consultation with academia and industry is regarded by us as a prerequisite for the effective role of the Hellenic Space Center in coordinating and promoting the synergy of research institutions and private companies in projects of mutual interest for the national benefit. We have had very fruitful interactions so far, and we are looking forward to the definition and support of joint projects. Last but not least, through our contacts with aspiring young scientists and engineers, we aim at identifying initiatives that deserve support and should be included in the framework of capacity building. Thank you for your attention.
Dear leaders of space agencies participating in this roundtable, members of the COSPAR Scientific Assembly, warm greetings to you all from Indian Space Research Organization. It's my pleasure to join my fellow panelists and address you all on India's and ISRO's perspective on international cooperation in space, science and planetary exploration. Continuing with the fruitful missions to explore Moon with Chandrayaan 1 and 2, Mars with MOM-1, ISRO is planning to follow on missions to these bodies and also missions to new destinations. ISRO is gearing up to launch the Aditya L1, India's first mission to study the Sun. This spacecraft will be placed in a halo orbit around the Lagrangian point 1 of the Sun-Earth system and will be continuously viewing the Sun without any occultation or eclipses to generate significant science outcome. Another interesting science mission will be the XPOSAT, the X-ray polarimeter satellite, slated for launch by mid-2021. This will be India's first dedicated polarimetry mission to study various dynamics of the astronomical sources in extreme conditions. The scientific outcome of the above two missions will offer great opportunity for the international cooperation. Already ESA and NASA have expressed interest to work with ISRO on the science of Aditya L1 mission. Further, ISRO plans for a broader international cooperation in these upcoming satellite missions to explore Venus as well. Through international announcement of opportunity, ISRO has already selected scientific payloads from Russia, France, Germany, and Sweden. India's third mission to Moon, Chandrayaan-3, will have a NASA instrument, the Laser Reflectometer Array, which will serve as a location marker for future lunar missions. ISRO is in active discussion with JAXA to realize a joint mission to the polar region of the Moon as well. ISRO has embarked on an ambitious human spaceflight program, aimed to fly internationals to space from Indian soil and bring them back safely. This will be the stepping stone for creating a sustained human presence in space in the future for India. ISRO is working with the space agencies of Russia, France, Japan, and USA on this important mission. ISRO is also contributing to the global space science community with the current space missions such as the onboard instrument AstroSat carried out phase-resolved polarization studies of the emissions from the Crab Nebula system. This unique polarimetry study has raised new challenges to understand high polarization emissions during off-peak phase intervals. Another instrument led to the discovery of the UV photons from epoch of reionization. The Mars Color Camera, the Mars Orbiter mission, has produced more than 1,100 images so far. Using these images, ISRO has prepared the Mars Atlas. Using the data from Chandrayaan-2 orbiter, the highest resolution optical image of lunar surface and the first full polarimetric measurement of permanently shadowed regions of the larger surface composition study of Moon are carried out. All these data and other scientific outputs are made available to the global scientific community for conducting focused research. I also would like to touch upon the recent reforms announced in the Indian space sector. With the emergence of technology advances in this area, communication, data revolution, India is witnessing a new business spirit and enthusiasm in industries and startups in space systems and services, which is going to create a new space technology ecosystem in this country. To meet the challenges and to proactively build conducive atmosphere for more entrepreneurial participation in space sector, India has announced space sector reforms recently. Today, we are looking at space as a means for furthering human knowledge through explorations while having opportunities that would unveil new business and drive growth. For this to happen, space must be safe, secure, and readily accessible to all. In this context, I want to say that India is in the forefront of the global platforms for evolving guidelines to ensure long-term sustainability of space activities. My greetings once again to COSPAR 2021 Scientific Assembly. I thank you all for this opportunity.
ISAS JAXA is promoting asteroid explorations such as Hayabusa 2 illustrated in this page. The original Hayabusa was launched in 2003 and rendezvoused with asteroid Itokawa in 2005 and then came back to Earth in 2010. Based on the achievement of Hayabusa project, ISAS JAXA developed Hayabusa 2, which was launched in 2014, arrived at asteroid Ryugu in 2018, and then brought back asteroid material on December 2020. They are very tiny spacecraft with about 600 kg, powered by fuel-effective ion engines. This is a comparison with two target asteroids, Itokawa and Ryugu. Itokawa is an oval-shaped stone-type asteroid with 500 meters as tip-to-tip length. On the other hand, Ryugu is a spinning top-shaped, carbon-rich asteroid with 1 kilometer diameter. On July 11, 2019, Hayabusa 2 executed the second touchdown operation and material sampling near the artificial crater. The spacecraft is hovering 10 meters above and then descend and touch down and ascend. Many boulders are scattered surrounding. Hayabusa 2 came back to Earth and dropped the sample return capsule. which landed on Australia Woomera on December 6, 2020. After transportation from Woomera to JAXA Sagamihara campus on December 8, a work then began to open the sample container inside the sample return capsule. On December 15th, an existence of black sand thought to be derived from asteroid Ryugu was confirmed to be inside. The largest grain is estimated 1 centimeter diameter and total collected sample will be about 5.4 grams of materials. ISAS JAXA and Hayabusa 2 project are supported by international space community from US, Germany, France, and Australia. NASA supplied DSN tracking support and exchange opportunity of asteroid materials between OSIRIS-REx and Hayabusa 2 in order to maximize asteroid science. DLR and CNES delivered mascot lander. Under COVID-19 situation, Australia accepted JAXA's 70th personnel of capsule return team. I would like to express our gratitude to Australia government, South Australia government, Australia Space Agency, Australia DoD, Australia Border Control, Woomera resident, Australia Embassy at Japan, and so on.
Hello, I'm Andrew Johnson. Despite its challenges, 2020 was a successful year for the New Zealand space sector. We had 6 successful launches from New Zealand, including deploying our first student payload. We are already preparing for the first launch of 2021. We're partnering with the Environmental Defence Fund in the MethaneSat satellite mission. The mission will use the latest scientific and technological innovations in sensor design, spectroscopy, data retrieval algorithms, and flux inversions to distinguish anthropogenic emissions from ambient sources and trace them back to their origin. New Zealand will take responsibility for mission operations and establish an atmospheric science program on agricultural methane that will complement the mission's main science on oil and gas industry emissions. Under agreements with NASA and Air New Zealand, next-generation GNSS receivers for the Cygnus mission will be installed on domestic aircraft and will collect soil moisture data as they fly across the country. The data will be used for scientific research into global water cycle processes and their interaction with climate, including effects such as flooding, droughts, and coastal erosion. Last year, we ran a series of virtual workshops with researchers at DLR, the German space agency, and in New Zealand to explore collaboration opportunities in propulsion, synthetic aperture radar, and optical communications technologies. We've just completed a call for proposals for Phase A studies on these 3 topics and look forward to some really exciting projects emerging from this. New Zealand is exploring innovation in areas such as propulsion to make space more accessible and sustainable. Our key initiatives include trials to integrate controlled airspace high-altitude vehicles and horizontal launches being developed and tested in New Zealand. New Zealand is also funding research for developing ion thrusters incorporating superconducting magnets on spacecraft. Sustainable use of space is not just about science and technology. Policy, regulation, and international cooperation are critical to ensure that we can continue to have access to space for scientific endeavours. New Zealand's regulatory regime requires that licensing decisions carefully consider the risk of orbital debris before granting permits for launch. We continue to trial Leo Labs' tracking service for satellites launched from New Zealand, incorporating data from Leo Labs' phased array radar system, including their radar here in New Zealand. We also work multilaterally through the UN COPUOS, as well as with other countries, on developing and implementing good practices for ensuring space sustainability. I'd like to commend our Australian cousins and hosts and the COSPAR Secretariat for enabling this hybrid meeting. I look forward to listening to the other presentations and the panel discussion.
Hello, dear colleagues. I decided to devote my short presentation here to international collaboration in space. It is well known that the joint effort ensures the best possible quality of space science, allows to share the spendings. Though sometimes such a deep collaboration looks like an extra management burden, but in the long run it definitely pays off. In the Soviet space program, despite all the secrecy, there was a broad experience of the international collaboration in space science. And this approach continues now. International programs are of high priority to IKI and Roscosmos. Starting from simple examples, more than a dozen instruments by Space Research Institute were flown since start of 21st century on European, American, Japanese planetary spacecraft. Russian instruments are selected for the future Indian Venus and Chinese asteroid mission. A number of payloads, mostly from European partners, are being prepared to launch on the nearest Russian missions. But delivery of small instruments is not just all what we have. The brightest recent example is Spectrum RG mission, which maps the X-ray universe with two telescopes, one German and one Russian. After 1 year, the map already includes 1 million of sources, and 3 years are still ahead. Finally, we will have the data for the decades of future scientific analysis. It is only with this joint effort the project could work out. Another example is a difficult path of the ExoMars project. ExoMars orbiter was finally flown in 2016 on a Russian rocket with two core Russian instruments on board. We got very interesting results on details of water ice on Mars and on minor components in the atmosphere. We are in a final stage of preparation of ExoMars lander and rover, which involve an unprecedented level of technical interdependence. We're expecting very high scientific return with the launch in 2022. In the frame of the ExoMars project, we also accomplished one more very important technical challenge with the mission ground support. For the first time, the Russian antennas regularly received the data from the European deep space spacecraft. In 2020, more than 70% of ExoMars data were received in Russia. Test reception was performed also with Mars Express. On the other hand, East-Track network helped a lot to cover poor visibility of Spectrum RG from the Russian territory in the April-May 2020. During the next year, the tests of uplink will be performed. This effort creates a very solid basis for the next joint projects. Future missions are continuing this pursuit. In the Russian lunar program, a significant European participation is planned, with such core elements as safe landing and regolith drill. Several agreements are signed on lunar exploration by Roscosmos and Chinese Space Agency. We hope that these projects, the first of which should be launched in 2021, will open the way for a deeper international effort on the moon surface. Just to mention about this year, a joint IKI-NASA working group is discussing the future flagship Venus project. Finally, I would like to thank COSPAR for the organization of these meetings of all agencies and for the principal support of collaboration in space science. However, we are entering now a very important historical moment when we need to define the post-ISS construction and the renewal of the human space flight to the moon. We have a challenge to extend the spirit of collaboration on the exploration agenda. And I am sure COSPAR can play a very productive role here. Thank you very much.
Hello, my name is Günther Hasinger. I'm the director of the ESA scientific program. And I will concentrate today on space weather and international cooperation. This is the fleet of ESA in the solar system, and you see that it is concentrated currently towards the inner solar system where space weather happens. In February 2020, we launched Solar Orbiter, studying the inner workings of the sun. And already in the very first pictures that we received, we have discovered a new phenomenon, campfires on the sun, which may very well be contributing or responsible for the heating of the sun. And Solar Orbiter has received a number of awards at the end of last year and is promising a great future. Now, in parallel, we have Epicolombo on its way to Mercury, and last year, it has flown by both Earth as you see above, and Venus, as you see in the movie below, working its way to the inner solar system, but simultaneously measuring already the solar wind and the plasma together with the other missions that we have in orbit, Solar Orbiter, Cluster, Bepi-Colombo, Swarm, and others work together like an orchestra with different instruments. And some exciting new results are coming out, in particular studying the aurora. And this is a beautiful picture from the space station taken by Tim Peake, taking together many, many measurements from Cluster and many other spacecrafts. Scientists recently have understood better how the magnetic substorms are created, which are disrupting the aurora and are creating some of the space weather. And just a few days ago, we have released a new study from Swarm, which actually indicates that the northern hemisphere is much stronger in space weather than the southern hemisphere, and this is due to the tilt and also the offset of the magnetic field. This is great prospect for the mission SMILE, which is a joint mission between ESA and NASA, between ESA and CAS, where we actually are planning to continuously observe the aurora on the northern pole, and the mission will be launched in a few years from now. Now coming to the astrophysics fleet, where our current working horses are Hubble, Gaia, Cheops, XMM Newton, and Integral. And I just want to show you two very nice results from one from XMM Newton and one from Hubble, showing the power again of international cooperation. So in this picture, a very large cluster of galaxies has been observed both with the optical telescope Subaru, with the X-ray telescope XMM Newton, and in the radio. And you see that the different components of the cluster, the normal gas, which is appearing green and red here, and the dark matter, which is appearing blue, are actually well separated, again indicating that dark matter is a substance of its own. And Hubble Space Telescope has recently made a study where they looked at one of these very strong clusters, and they were able to make a model of the dark matter and have actually found that the dark matter is much more clumped and much more clustered than originally anticipated. And this is actually a possible explanation is that dark matter is made up of primordial black holes, which is getting new interest. And with this, I would like to thank you and wait for an interesting discussion.
Hey, I'm Thomas Zurbuchen, the head of science at NASA, and I'm so excited to be part of this important panel. From decades of experience, NASA knows that leveraging the power of its relationships accomplishes big goals. At NASA, we do that daily, in space and on the ground, and by doing so, we improve the lives of people on Earth while advancing our understanding of this planet and of space. Because we inherently value diversity and principles of openness and transparency, NASA has and will continue to set the standard for peaceful cooperation among diverse nations. More than half of our cooperation is with a small group of about 8 valued countries, but in recent years, there has been a wonderful growth of nations of all sizes showing an interest in space, whether they have had their own space agencies or not. They all have scientists making discoveries, and the inspiration of the world's ever-growing accomplishments in space is not limited to borders. We know that we need to extend our relationships and publicly available data, tools, and expertise to emerging partners. So by growing our cooperation and increasing our nations we partner with, we know that we will all learn new approaches and perspectives and make new discoveries on behalf of all of humanity. I think organizations like COSPAR share my view that science spurred by diversity of opinion and backgrounds can help bring hope in these uncertain times and help us collectively solve our problems and unify us all as one species of explorers. This is why I'm excited to announce a new opportunity for partnership today that we believe will fit well within COSPAR. This initiative builds on what NASA already does so well, encouraging partners to grow and learn together with us as we collectively advance civilization-level science. The kinds of things that make all humanity gasp in awe, like the first images we returned from Mars, or the first time we set foot on the moon. Under a recent agreement with the United Office for Outer Space Affairs, we will be working closely to leverage our publicly available scientific data and support new and innovative commercial partnerships with American companies to achieve the United Nations Sustainable Development Goals, which seek to create a safe and prosperous future for all of humanity to enjoy. The agreement also supports the work of COSPAR to establish norms of behavior and principles such as transparency and due regard that provide the clarity necessary for safe operation in space. In addition, we soon will issue a request for information from U.S. institutions on innovative ways to increase the mission development capacity of our newer partners. We will seek the best ideas that will support students and early career professionals from emerging partner countries and enable them to work side by side and learn from our experts as they develop already funded CubeSats and SmallSat projects, or their own projects as they want to bring these to the table. Our hope is that this hands-on experience will build upon the scientific method that we've already pursued and in the conduct of Earth and space science, and provide a new and useful platform for our collaboration with emerging partners. And it's an approach we are focused on in our new missions as well, to try and do important science with smaller spacecraft, smaller missions. We intend our first mission development activities to be focused on space weather and heliophysics science. Consistent with COSPAR's task group for constellations of small sats and the goals of NASA's agreement with UNOSA, we help to contribute to an international constellation of space weather small satellites. A request for information will come out shortly that will be broad enough to allow for multiple avenues to accomplish that objective. I'm really looking forward to the release of this request because I truly believe that it will help us build and extend our relationship with new partners and create a more inclusive world where the power of science for all unites and provides hope for nations of all sizes and capabilities in this amazing global act of exploration in which we all take part in some form. By leveraging innovative partnerships involving governments, institutions, and even commercial companies, we can increase capability and capacity worldwide and create a future in which more of us can even make greater contributions to expanding the frontiers of human knowledge and our understanding of Earth and space. I know that with the dedication and creativity of the COSPAR community and with the help of our many friends and partners who share our passion for the great pursuit of knowledge about our planet and the universe, we can help build a common foundation for greater scientific discoveries. It will be a foundation on which the next generation can build, and one that inspires and contributes to much needed sense of amazement, wonder, and hope for the future. So to everyone, I thank you, and I look forward to continue to work with you this year and many years to come. Thank you so much.
Okay, then.
Okay. Thank you very much for the videos. I understand in my screen as well that some of the more complicated slides bandwidth will not permit resolution, but I hope everyone got the messages from the various presentations, and I thank the panelists very much for contributing them. We are going to have a discussion now. We have some good questions that have come in while you were talking, while the video was playing. I'm going to start going through these now, and in some cases, I'm going to expand on them because I think there are some things that that make them even broader, perhaps, than the original question. So when I give the question, I will I can see every one of you on the screen, and so you can nod, you can raise your hand, you can put your hands over your eyes if you don't want to be responsible for answering these questions, and we'll see what kind of dialogue we can have. The first question I'm going to deal is it concerns Earth science, and it reads, despite the tragedy of the pandemic, climate change remains the immediate concern for life on Earth. Do the agencies have explicit intentions in protecting Earth and humanity? And how do the agencies plan to cooperate in this extremely important sector? Now, I'd like to expand on this just a bit, if I may, and your answers, because in many of your presentations, this issue came up, and you talked about what you were going to do in earth science, and the cooperations that you were having, and so on. And this is one of those broad themes, I think, that go through the whole International Space Program. Essentially, the space has an essential role in addressing the existential threat to our civilization, which is climate change, and also, of course, things like space weather. Now, no single one of you, can contribute to all these things, or any of the the major things, or any one theme. In this case, earth science. But it's the collective actions of all of us that somehow these themes have to be pursued. And I wonder, actually, if you think of your space programs in that context, that you are, in fact, part of a larger effort. And the reason I ask that is that, space is often it's a competitive issue. You remember the space age started with the competitions between the Soviet Union and the United States and so on. Governments tend to support space and so on, and in terms of what they contribute to their own nations. Not an unreasonable position, but are you, in fact, not only do you view international cooperation, for example, as part of the glue that holds this whole thing together? Are you able within your own agencies to essentially get support for doing something for the common good? And so I extend that, and I look forward to someone. You were paying attention to the question. Andrew, you mute yourself.
Yeah, thanks, Leonard. And yeah, it's a great question, and I think it's one that's really apt for the issue of climate change. I just wanted to comment really on the issue of sustainability and how it's really core to New Zealand's space identity, not just in how we behave in space and support behaviour in space, but in what we use space for. And I just wanted to highlight an example. Just you talk about rising above specific national interests and doing something in the common good, and that's the methane satellite mission, which in many ways is the first New Zealand government-sponsored space mission that we've actually undertaken, and that's a collaborative effort with the US based NGO, the Environmental Defence Fund. So the methane sat mission is going to be a state-of-the-art instrument with a 200-kilometre swathe, but also with the sensitivity and the resolution to be able to detect sources of oil and gas methane. And that we hope will contribute to driving down emissions in the oil and gas sector from methane by 45% by 2025. And I just think that's really key to New Zealand's identity in space, and also just an example of what you're looking for there. Rising above national interests, looking for something in the common good.
Thank you. Thomas, you want to?
Sure. Yeah, I can talk about it. Look, when NASA was founded at the beginning, of course, we were in a tremendous international competition. But I think what really helped us in many ways, and I always wondered about the wisdom of the early leaders, is that the international cooperation was built in from the very beginning. It is true that at a given time, any one of our space agencies need to convince their governments and their taxpayers, in fact, to support the investments that are being made in each one of our activities, and NASA is no exception. Every year, a process by various stakeholders decides what the total funding level is that we're going to have, and every other country has similar type of processes. But I think what we feel like, and I think just in general, especially when it comes to science, there is only one science, and that's international science. And for us, that has been the foundation of our policies. For example, how we handle our data, how we see cooperation, whether it's with you just heard with the announcement that we made, whether it's with our very well-known and trusted partners, many of which are here in this room, or whether it's also with new partners. We think it's our goal to really have that common good there. It makes absolute sense to do that, and multiple examples were given in various talks. For example, I put in the chat URL of a project that we've worked with ESA and JAXA during COVID, in which we took all of our data in a common team working together to provide information for decision makers during this crisis we're all in as an Earth. Climate related questions of the type that our colleague from New Zealand just talked about, methane, one of the big puzzles in greenhouse gases. Where is this methane coming from? What is really the predictive, how can we predict what the methane is going to be? It turns out to be much more important than many previous models predicted. So those things are global type of questions, and making kind of the data available, but also working together as a single science community is the only way to do science. And for me, that in our opinion, and so it is important, therefore, that as we talk to our national stakeholders about money, about goals, that in that narrative, the global kind of stakeholders are also part of, and that is every day of my life works that way, right? That two sides of the medal, so to say. The value to, of course, our country and our taxpayers. At the same time, the value and the importance that we give to the international cooperation, because the problems that we solve are truly international.
Thank you. Jeannie.
Yes, thank you. As you know, climate has a very strong priority in France since my country has been instrumental in the success of the Paris Agreement in 2015. And we heard with a lot of pleasure that following the election of President Joe Biden, the US will be back in this Paris Agreement. And since then, President Emmanuel Macron organized the 4 editions of what is called the One Planet Summit in order to create the coalitions to tackle climate change. And at the CNES level, we developed the Space Climate Observatory. We have a total of 27 organizations participating in this observatory. And we are deeply convinced that the only way to tackle climate change is to do it in international cooperation. This is exactly what we are doing. But I think that, of course, pandemic is, let us say, hopefully a short-term issue, but climate change and tackling climate change is probably the most important fight of this century. And I am sure that space will play a very important role. I want just to remind you that when speaking about climate, you speak about 50 essential climate variables, and out of these 50 variables, 26, which is more than half, can be observed only by satellites. And so it is why it's so important. Thank you.
Excellent, thank you. Could I ask, yes, someone else?
Right.
Leonard?
Yep.
Yeah.
Okay. Oh, who's I didn't know. Did you?
Maybe I'll just say a few quick words. Sorry. Is that as has been mentioned by previous panelists, I think that one of the key things that comes out in this particular topic is the international collaboration and the international collaboration around science. Yes, we've all lived through a very interesting year last year with 2020. But for those of you who can cast your mind back a little bit further, Australia was subjected to serious bushfires at the end of 2019. And one of the things that really struck us was the immediate offer of support and assistance by a number of the international space agencies, offering a lot of support and data coming through. So I think that speaks to that common humanity and that common capability that people all, scientists and the international community, rallies together and says, you know, there's a need here, and so we need to support each other. And that has sparked a number of different conversations as well too. As a young agency, we're growing and we're developing our conversations, obviously. But then there's a number of discussions with the US, with Canada, with French research agencies, with DLR, etc., with the Italian Space Agency, in terms of supporting Australian and those agencies' collaboration in exploring how we then tackle some of these more immediate needs that we have and experience to try and deal with some of the situations as we're trying to work through them at the moment, but then also apply that to the longer term solution. So it's a great opportunity in this topic to again for Australia to say thank you to all the support that was offered from the international community at that time.
Thank you very much. Gunther.
Okay, I think Thomas has already mentioned it, but you know that space climate and Earth observation are an extremely important priority at ESA, probably one of the strongest programs at ESA, and you know that also our Earth observation director, Josef Aschbacher, has now been elected as the next DG of ESA, so we will see more priority and stronger cooperation there. And this dashboard that Thomas mentioned is clearly very successful, but it's just the beginning. There's also a very large room for more international collaboration on that.
Very good. Yes. Oh,
Mr. President, may I?
Lost you here, Walter.
Yes, thank you very much. I would like to come back to the sentence Thomas Zubuchen brought up, actually, when he showed the connection between climate change and the budget. And your question was whether we can convince our decision makers actually in coming up with missions which actually have some kind of common good. I would actually rephrase it. At least in Germany, the chance and the option that we are able to tackle climate change with space was kind of a door opener to move space from a more scientific, pure scientific area to an area where we have some kind of common good for living on Earth, which actually brought us to the position that we were able to get more funds. Günther just mentioned the Earth observation, the biggest program of ESA, and Germany contributes with the biggest part over there in this program. And not only within ESA, by the way, the data of Copernicus are free for the public, so they can access, they can get these data free of charge. Even if we have bilateral, our primary focus is on missions which are related to tackle some topics in regard of climate change. For example, we work together with our friends in France, with Jean-Yves in a program or mission called Mission, to tackle the topic which was also mentioned by Thomas Sobuch regarding methane. And together with our friends in NASA, JPL, for example, we have a program also with GRACE. All these missions are actually focused to tackle climate change issues. So I would, let's say, turn around your question. It's not something that we have to convince our decision makers. The knowledge, or actually that it came that it became public, that a lot of topics are only solved or tackled by space, opens the door for bigger funds and for acceptance of space, at least in Germany.
Excellent, thank you. Let's see, I've got a call on somebody. Mom G, would you like to enter into this discussion? How's China view all this stuff?
Yes, actually, the Chinese government is paying more attention to the global change since. Just a few years ago, China launched a TANG satellite, which will measure the CO2. We monitor the atmosphere, and in the future, we will use the small satellite to monitor the atmosphere, the ocean, and the land mass. So that get more attention from the government.
I mean, one of the features that always goes with our science and so forth is since it's a global problem and we're tackling a global problem, and we have cooperation and thing, but data sharing is always one of the key events of this, because that cannot be a nationalist issue if it's going to be successful. What's your assessment, folks? Are we doing a good enough job on that? Because that's how you turn a regional program into a true, even within cooperations, but into a true global participation in a global event. And so, anyone want to comment? And Anatoly, did I? Yes.
Okay. I would like to support this, Leonard, your idea about data sharing. I wanted to participate in the previous discussion, but this is what I exactly wanted to say, that actually even if these are national missions, which are launched on the national basis by agencies, they complement themselves in coverage. For example, if we look on the natural ecosystems monitoring, it's a very important part of the climate change, especially in the boreal zones, which is very typical for Russia. Thanks to this international fleet, we can cover every piece of Russian territory maybe 17 times per day. And even taking into account that we have cloudiness more than 60% of time, if this international fleet allows us to get a very comprehensive picture of what is going on in very remote areas. And this balance of these remote areas is very important constituent, for example, for carbon balance. We need not only to count the artificial sources of carbon dioxide, but also natural sinks and sources. And these are mostly very remote places. That's why I think the data sharing on the level which we have now is already very important, crucial part of our success in climate science. But of course, we can, still a lot of things should be done to promote it wider. I mean, that some maybe include some agreement similar to agreement on meteor data, which will allow some data available on more legal, on more solid legal basis. Thank you.
Good, thank you. Let's say, Dr. Samanath, would you care to join in onto this? About India view all these issues?
May I ask some? May I speak something
Oh,
from
yes,
the JAXA?
by all means.
So that the climate change is a very urgent issue to be solved. And then so that the JAXA has the input several Earth observation satellite on the air trains. And then so that the carbon dioxide measurement system of an precipitation measurement satellite. And then so that the similar to JAXA, ESA and NASA have input the Earth observation satellite on the air trains. And then so that the, so in that sense, under the collaboration of the International Space Agency, we are making the Earth observation system. And then so in the sense, and then from the space agency, we can show the some of the solution to the global people in the world. And then that is the, in the sense, the international collaboration is between space agencies is very important to make a solution even in the climate exchange.
Thank you. And I'm going to take, we'll have one more. Dr. Samanath, did you want to comment, or and which then I think I'll try another question.
Thank you, Chair. I would like to tell you that for the climate change in ISRO, it is an institutional mechanism. We understand that the essential climate variables cannot be measured from space alone. Space, of course, is one way to measure some of those measurements, as Ron Wall said about that. But then we created an institutional mechanism in India where all the research laboratories who are working in this are establishing ground-based observations and also space-based observations. And we are working in a national level on climate change related issues. So that's the first thing. Then second is about the missions that ISRO has undertaken. We have been continuously putting satellites in the last decades on various aspects of related to measurements of atmosphere, land, ocean, and we also had collaborations with various space agencies with regard to data sharing, and we continue to provide this data through our already existing space-based observatories, and we are replacing them. Whenever they are aging, we are making sure that our next generation spacecraft is up and running, and also the instruments are of better quality. I think this is something that already been well known to the community, and we make sure that this data is shared across all the researchers so that the global climate change related research is supported by ISRO through these efforts. And we also looking at various instruments in different domains. For example, we are looking at for example, that we are looking at the radar-based observations. We also have observations specifically through our scatterometers, which are giving a very high periodicity observations, which has not been there earlier. And we are continuing to put in a series of communication and remote sensing satellite these platforms for specific observations leading to climate change research. Thank you, Chair.
Thank you very much. I'm going to go on to the next question. And actually, the question comes in for you, Dr. Samanath, but I hope that I'm going to, as always, I'm going to broaden this. It says, the question was how ESRO handled the difficulties posed by the pandemic and could release 2 launches in 2020. That's a success, I think. But if I may broaden this just a bit, because Thomas Zurbuchen sort of touched on this, that space, the question is, with the pandemic raising, what is space able to contribute to that? And Thomas mentioned some efforts, that have been done in terms of, data collection and others. And I believe there are things ongoing out there that, to what extent were we good citizens of the planet and, help with the pandemic, whether it's economic, information or so forth. And so if I may make the question even broader, you're welcome to tell the world, Dr. Samanath, how it was you managed to survive the pandemic and launch? I mean, I think other countries have done that too, but apparently.
Yeah, very good. I think this pandemic was really a big challenge for us in our operations. We had a series of launches scheduled that couldn't happen. We had to postpone primarily because the way we conduct our launches, it is a pan-country activity. Various sub-assemblies comes from very different parts of the country. It has to move, which couldn't happen. Then, of course, our people going to the launch center, it has to cross our different states of the country where we had restrictions that was imposed by the COVID, and the mobility was limited. So what we did is we had to overcome such difficulties. So one of the important things that we did is we created how to launch it remotely. So we started trying to link our other launch center where it will become the control center of the launch. So that's the first thing that we did. We could create control centers away, something like 800 kilometers away, and then started doing the testing of the rocket sitting far away. And we could stage-wise and assemble and test them remotely using the staff available in the launch site itself without moving the experts there. And we reached the launch situation by very minimum people. And that was something really remarkable. And we could achieve that remote launching concept. We call it virtual launch control center. The way we meet today, same way we launched it virtually by sitting far away. That was something that we could accomplish in very short time. In 2 launches, we could do that without any hitch. And now it has become an SOP now in our operation. So we are continuing to do that way. And this year, we will have regular launches in that mode. So that is one way. But our industries, I must salute our industries in this country, which continue to work very well, even under the pandemic. And they were finding some way or the other to keep the system running. So we were not short of hardwares or systems for our launches and satellites. Thank you.
Okay, thank you very much. Thomas, you, I think, touched on the issue of activities that occurred that actually, benefited in being able to benefit the world in the sense of being able to, use space to contribute to the, knowledge of how the pandemic was impacting the economy and various other things. Am I right about that?
Yeah, you're right that the dashboard that I put into the chat earlier, eodashboard.org, I think is the URL. Basically provides data for really near real time, but also historic data of how the pandemic is really having impact, on Earth. Now, there's a number of decision makers who need and want to know that, and in various countries that basically benefit from seeing the data, such as how many planes are flying, what are the shipping lanes that are opening up, airport activity, as well as pollution and other type of Earth type parameters. I just want to point out as a side comment that, the Earth on COVID gives us new insight about our planet and its complex interconnected system than we had before. We learn about these connections in a very unusual configuration in an unusual state. So we should not miss the opportunity of learning everything we can about our planet from this situation now, as dire as the motivation may be for that difference. For example, the large reduction of carbon dioxide, one of our principal culprits of the Earth's greenhouse effect, is the emissions of that was massively reduced at 30 to 40% in many areas, or 20% in others. And so basically what that helps us do is really learn how this long-lived gas is really affecting the global distribution based on these other data that are now available. And so for us, it's really about both be useful, but also never miss an opportunity to learn. And I think that is, as we go forward, I think that the interesting part that we're really having in front of us, and I know many other agencies look at that too, is the question whether the distribution of this virus and And as it propagates forward, what are the seasonal dependencies, the temperature dependencies, humidities, and so forth. And so mapping data sets that come from global health type of environments to kind of a global environment as observed from space is a very interesting area to look at, just like it is with other life, life that of course affects also how ice melts in the polar regions, or how fires distribute organics. We also know now life from the smoke that comes up, whether it's in Australia or kind of areas in Africa, or also in the United States, so much in the western part. So I think those are really important and interesting and useful areas for investigations globally.
Good. Thank you. Gunther?
I have to unmute. Len, thank you very much. Very shortly, first I would like to say that apart from a few days in April where we lost some satellite operations because of the restrictions of COVID, all the ESA spacecrafts have actually continued to operate, which was a huge relief also. So we are producing science and data, and in particular the Earth observation system that went into the dashboard. I would like to make one special example. So for instance, on this International Space Station, we are now studying a COVID-related medicine. So we are also using space in order to help medicine to overcome our biggest problem.
Thank you. Dr. Kunanaka?
Yeah, thank you very much. So I'm working in the space science in the JAXA, and so that from the space science division, it might be very difficult to show some of the solution to the COVID-19, but through my video message in this assembly, I have already explained you. Last month, we succeeded to retrieve the Hayabusa 2 capsule at the Australia Woomera. So in this work, JAXA and Australia Space Agency cooperatively work in this work, and we succeeded to do that. So I want to say, so from the space segment, JAXA and Australia Space Agency show our spirit and motivation to fight against COVID-19. So that is our achievement from the space segment to the world.
Thank you very much. Carl?
Thank you, Leonard. Three things I wanted to mention. Absolutely, as Thomas mentioned, there's going to be a significant amount of learnings that we can take from the data, from the special circumstances that we've just experienced over the last year. And the data, not only climate data, people movement data, logistics, etc., all of those sorts of things. People will be studying these data sets for years to come, and the approach and the analytics, the artificial intelligence, machine learning elements that will be going over those data elements themselves will actually extract some significantly positive responses in terms of how the world can respond in terms of delivery solutions, etc., and movement solutions, and the effect on the economy, so that we can do better the next time, if there is a next time, so to speak. The second thing is, and this goes to Dr. Somernath's comments there, and that is the pandemic has also revealed new ways of working and applications of technology that we now need to adopt, that we had to adopt, and that we will continue to adopt in terms of remote operations and robotics and such like that. So the advances that are coming through there are all going to be fundamental and applied in our exploration of space in the near-term future. And then that human element, the third thing Dr. Kunanaka mentioned, it was an absolute pleasure to work with the Japanese Space Agency and NASA as well too, as in the middle of a pandemic, we were working very closely under very strict regulations and restrictions to see what we could do to help JAXA with sourcing 70 scientists, 70+ scientists, and the NASA personnel as well too, to come into the country, fully quarantined for 2 weeks at the time. But it spoke to, again, that international collaboration
that this spacecraft was returning, and it had a specific date that it was coming back in. And so within all of the COVID restrictions, within all of the COVID practices and the rules and regulations through multiple government departments, including on the Japanese side, there was still that desire to collaborate and to see the success of the mission. So again, thank you, Dr. Kunanaka, for allowing us to be part of that success. It was fantastic. Thank you.
Okay, thank you very much. I'm going to go on to another question here, so because the clock is running and the questions are coming in, and this one is a tough one. You may all decide that you want to put your hands over your eyes or something. It says, how do space agencies plan to mitigate the threat imposed by mega constellations for secured space science activities? Anybody want to try that one?
So I can start. This affects all of us. This very important problem that we have in front of us, and also an opportunity, like so often innovation is. I mean, first of all, who could say that providing internet to communities who are far away, especially during a time of isolation for so many of us, we're talking to each other because we have internet where we are. Who would say that that's a bad idea? Who would say that that is not an absolute laudable goal for so many of the companies, no matter where they are? And we're aware of companies being developed in Europe and in the United States and beyond. I mean, we're aware of these companies. Like so often, whether it's climate or whether it's low Earth orbit in this case, we have a common good. And it's absolutely critical for the international community to come together and deal with the resources that are there. In this case, low Earth orbit as a place to do amazing research and utilize for our national needs as well. And so basically what's critical, and I think what we have done is really to talk about these standards of behavior that are absolutely important to be adopting for all of these partners going forward. For what it's worth, the experience we have in the United States, we found our companies to be very strong partners. We have active dialogues in all issues, and we're learning a lot as we go forward. We have actually posted some of these initial standards. We're in discussions with our partners to go forward, and what we're observing is, of course, standard observation. I've worked in multiple countries, and it's no surprise to any of us that it tends to be that innovation kind of outperforms in speed some of the regulations that tend to fall behind. And I think what we need to do as an international community is catch up with these and make sure that at the end we achieve both goals. Goal number one, these kind of important needs, whether they're from the business side or, as I just talked to you about, from the side of fairness and perhaps even humanitarian needs, telemedicine and otherwise. These needs are being addressed from space. That's a strength. What's wrong with that? But at the same time that we retain the utility of low Earth orbit and kind of the impacts that comes from such deployments to be in a way that we all can benefit from the resource that we have here in low Earth orbit and beyond.
Okay, thank you. Walter, do you?
Yes, thank you. There's no question that constellation and small sats are a huge opportunity, and I'm not going into detail because the question is actually the question, how are we going to tackle the question of space traffic management? And as Thomas Subuchen just mentioned, we have to accelerate, we have to gain speed when it comes to regulation. And the question is, how do we handle the regulation? Are we going to set up some kind of regulation by a group of like-minded spacefaring nations, or are we going to put it from the first step on a broader base? And Germany, for example, was president of the European Union in the second quarter of last year, and space traffic management was put by Germany on the table that the European Union actually tackles this issue and is now discussing space traffic management on a European base. But bottom line, our target is to keep it or to lift it on the level on the United Nations. We are well aware that we have to gain speed, and Thomas is 100% right that actually the commercial path is right now moving very fast, and the regulation part is falling behind. But to make sure that we have a well accepted set of regulation, at least from our point of view, we need to lift this discussion of space traffic management on the level of the United Nations. And that's what we try to do.
Thank you very much. Gunther.
Maybe just one short remark. Also, I mean, the space debris issue is a big one. I mean, that it comes out of mega constellations, but also the overall satellite bulk. And I just want to mention that ESA has embarked as the first agency to actually actively control space debris and bring down at least one asset from space. The Adrios mission is now moving forward. And this is hopefully an example. I mean, we have to also include in these regulations that everybody who brings something up also needs to make sure that the space debris comes down again. And I hope that these international pushes for regulation will go in that direction.
Good, thank you very much. I think, Jean-Claude, I think we have reached the end of the scheduled time for this. Am I correct?
Yes. You have many questions in the backlog. Up to you and the panelists if they want to go on for another few minutes.
Maybe we could answer some of them in the written form.
Yes, I don't know whether you are, some of you are already registered to the assembly, because there's also the option for view-only attendees to ask these questions by chat box on your profiles, but that may not be the case for all of you. The only thing I'm considering is the time pressure for our Australian and New Zealander colleague. It's already middle of the night. I don't know, up to you, Len.
Well, they look remarkably cheerful, and but I do think we ought to stick to the schedule here. I'll tell you what, we'll take these questions. They came in the Q&A box, so you haven't seen them. We'll distribute them to you, and then we'll find a way to put the answers out someplace. And I think that we got through, as